Hello, guys. Good evening, all. Thanks for joining us for another series in our program. Thanks for joining the Asha Nigeria, the AWC Nigeria user group. Yeah. So today we have an interesting speaker, David. So, David, can you say one or two for the team?
Hey, hello, sir. How you doing?
Yes.
Anytime I see you, I'm always motivated. I'm like, I know what the goal is. well, well,
I've, I've been busy working today, so I just came up from work like 15 minutes was in a
oh wow,
conversation
yeah.
with Microsoft. So, but actually, yeah, it's sometimes difficult to switch in between technologies, right?
Hey, it's a multi-cloud world, and again, like people
Yeah,
people are sort of like getting more familiar with sort of like the way that things work in the world in the world that we're in these days. It's a multi-cloud world, and that's the
exactly,
truth. Yeah.
exactly. Yeah. So, David will talk us through on securing web applications environment on AWS. So, David, yeah, you worked a lot in the cloud. Yeah, web app changed a lot on how we secure applications. The cloud compute, networking, storage have changed, totally changed. So AWS has a unique way to do things, to do it. Yeah, it would be nice for you to take the stage and then tell us, share your knowledge, and let's have fun. And if you guys have any questions, you can drop it up and I'll take up the questions and then ask any question to the floor back to David. David, the floor is all yours.
Yeah. Thanks very much, sir.
Yeah.
Thanks very much for that lovely introduction. So I think what we're probably going to do also is we'll probably pick things up from where we stopped yesterday. So yesterday we started talking about the security and entry point into AWS. But we didn't finish that conversation yesterday. And thinking that what we can sort of do here is we can sort of pick up the conversation from where we stopped, progress and complete that, and then we
Okay.
can go into securing web applications and have conversation around that. Also, just to remind people that there will be a quiz at the end of this session. The quiz is
All
not
right.
necessarily tied to what we're going to be discussing, but it's still going to be a quiz. And there is a very, very interesting gift to be won at the end, or a very interesting prize to be won at the end of that. So the person that gets the highest score will win a certification voucher for the AWS Security Specialty Certification. That's something that's worth about $300.
Exactly. Yeah,
Yeah,
that's quite a
yeah,
gift,
yeah,
I
and
must say.
and that's yeah, and that's something that people like Satchugo. That's really nothing. It's it's type of money that you spend, on a few drinks here and there. So but for some of us, that's like quite
Ah, come
significant.
on.
so so, let's get into that. So yesterday when we were talking about identity, we're talking about um, that when we're making requests from AWS SDK, from the AWS CLI, from the AWS Management Console, we said those requests are signed. They are automatically signed for us. So what if we're making the request by ourselves? What if we're crafting the API call to the AWS API endpoint? Are the requests also going to be automatically signed? No, they are not automatically signed. So in that case, we need to implement the signing by ourselves. We need to make sure that pass the we need to make sure that we pass the information into the authorization header section, and then we need to make sure that we include that in all the requests that we are sending to the AWS API endpoint. So let's move on very quickly in the interest of time. Let's talk very quickly about AWS Accounts, which uses some user credential information. So when we're talking about, and this is just a quick overview, when we're talking about entry point into AWS and understanding the identities that we can use to authenticate, to gain access into AWS, we have the root user, which is the default user that's created when we sign up for an AWS account, but it has unrestricted access. So ideally, this is not a user account that we want to be using for our day-to-day work. This is a user account that we only want to use only when we need to use them. So there are a few cases when we need to use the AWS root user account. So for example, maybe we want to delete our AWS account completely. We need the root user account to do that, right? And a few other things we need the root user account to do. So what we ideally want to do is we want to create an IAM user and then use that IAM user to access our AWS environment. So here's some very quick information around best practices around security of the AWS root user account, some things not to do and some things to do. So for example, avoid using AWS root account for day-to-day activity. So don't use it for day-to-day activity. Instead, what we want to do is we want to create IAM user accounts with strong passwords, with MFA implemented, and then use those. Here's another good practice. Do not use the root account for programmatic access. So don't use the root account for making API calls, for integrating in code. Don't put root user credentials or embed them into any application or code. That's not a good thing to do. So instead, again, create your AWS user account, create your AWS roles, and use those instead. So here's some other information around user access keys and security in AWS. So we mentioned this earlier that a user account in AWS can have access keys created for them. And a user account can have 2 access keys at the same time. So we can set the access keys to be active or we can set them to be inactive. So for example, if we're responding to an incident, we may want to set an access key to be inactive if we suspect that there's been a breach or there's been a compromise with regards to that identity. So we want to set that to be inactive. Let's move on. So when it comes to the access keys, access keys are what we use for programmatic access in AWS, whether we're making programmatic access calls through AWS CLI, AWS PowerShell, or through the SDKs, we use the access keys for those. So here are some good practices around securing the access keys. Number one, we want to regularly rotate them. Rotate them regularly. So this is based on time-based security. Every security can be compromised given sufficient time. So rotate the keys regularly. If you suspect that there's been a key compromise, you want to disable or you want to delete access to the keys in order to revoke access to the keys. So keep that in mind. So that way the key won't be usable for API calls. Also, what we want to do is we want to make sure that we use different keys for different entities. So that way we can trace things. So traceability is important. We can say this application use these keys to make these changes because we have a key that's dedicated to that application. So use different keys for different entities. Also, constantly monitor for keys that are not being used in your environment. You'll be thinking, how do I monitor for keys that are not being used in my environment? Well, there are different ways to do that. AWS has a report that we can download for AWS access key usage, so we can leverage that report to get that information. There's also an API, which is the Get Access Key Last Used API. So we can use that API to get the information about when the last time a key was used, and if it's not been used for a long time, we want to remove that. Don't embed these keys in code. Do not do that. So what we want to do instead is we want to put them in a vault somewhere, maybe leveraging other services, or secure services like Secret Manager, put them in the vault, and then call them or access them from there in a much more secure way. And also, you want to have a plan for leaked access keys in your environment. You know, the saying goes, if you fail to plan, you plan to fail. if you don't have a well-defined plan for what your incident response teams are going to do, if a key gets compromised, then you won't know what to do. So number one, what do you want to do if your key gets compromised? Number one, you want to determine which identity has the access key. So that's number one. Which identity has the access key? Locate that identity. Then number two, what we want to do is that we want to check what permission does that identity have. So you want to check the permission. So number one, check the identity. Number two, check the permission of the identity. So that's important. Then number three, what we want to do is we want to revoke the access for that. And then another priority for what we want to do is we also want to look for any outstanding sessions that the key already has enabled, and we want to revoke those outstanding sessions. And then number four and number five, we also want to invalidate any credential that may be used by that user. So we want to invalidate any of those credentials that may be used by the user, right? So those are some of the plans that we want to put in place in case an access key gets compromised. So let's move on very, very quickly in the interest of time so we can get into the web application aspect today also. So let's look at some quick information around AWS IEM policies. Just some quick review just to remind ourselves about this. So AWS IEM review. So AWS IEM, it's a web service that controls access to AWS resources. So we can use IAM to control who can use our AWS resources. That is referred to as authentication. We can also use it to control what the identities can do against our AWS resources. That's referred to as authorization. There are two main types of IAM permissions that exist. So we have identity-based IAM permissions and we have resource-based IAM permissions. And both of them, they are very identical. Actually, in appearance and in function, they are very identical, but there's a slight difference. Identity-based IAM permissions are applied against identities. So we apply them, we attach them to a user, a group, or a role in AWS IAM. Resource-based permissions, which are attached to resource-based policies, are attached to a resource directly. So maybe attached to, maybe an example of that would be an Amazon S3 bucket resource bucket policy or an AWS KMS key policy. So those are considered to be resource-based policies. Another information to just keep in mind when it comes to AWS IAM is that there are three types of policies. We have AWS Managed, we have Customer Managed, and we have Inline Policies. Let's have a look at some of those. We'll have a look at some of those in other slides. So when it comes to roles in AWS, roles allows us to assign temporary credentials to principal entities, right? So that users, to groups of users, or to even other roles, or to users in other AWS accounts. So roles allows us to attach temporary credentials or temporary credentials to those identities. So when we're using our roles, there are two types of policies that we typically work with. We work with a policy type called trust policy. The trust policy is where we define who is allowed to use this role, who is allowed to assume this role. That could be an AWS account. That could be a user in another AWS account. That could be an AWS service, maybe an EC2 instance, a Lambda function, an AKS instance, right? So we can designate the Amazon resource name of that resource and say this resource is allowed to assume this role. So we define that in the trust policy. And then we have the permission policy, which is where we define the actions that the role grants permission for. So that's where we define what permission that the role can be used for. So we define that in the permission policy. So mentioned this earlier in terms of many organizations, they maintain more than one AWS account, right? And in those cases, using roles and cross-account access, what we can do is we can define user identities in one account and then use those identities to access AWS resources in other accounts that belongs to our organization, right? So this approach is a delegation approach, again, leveraging roles with temporary access. There's a lot of details that we could go into in terms of how that happens, making call to the security token service, but we'll save that for other conversations that we'll have later in this study series. So another thing to also keep in mind that there are other types of policies that exist. So we have session policies that also exist. So session policies, they are advanced policies that we can pass as parameters when we programmatically create maybe a temporary session, or maybe for a role, or maybe for a federated user. A federated user means a user that does not exist in AWS IAM. It's a federated user. So that could be a user that we're bringing in from maybe Okta or some other web identity provider out there, or maybe even from Active Directory on premises. So if we want to create a session or a role session, programmatically, what we can use is we can use the Assume Role API operation, and we can leverage that to create that programmatically. So let's quickly conclude this aspect. So we talk about the web security, web application security part. So let's talk about IAM policy types. I mentioned this earlier. There are three main IAM policy types. We have AWS Managed, Customer Managed, and Inline Policies. So AWS Managed Policies, those are policies that are automatically managed by AWS themselves. So AWS regularly updates them also. So, and that's one of the other things to keep in mind, is that there may be cases where AWS has created a policy, and then AWS decided to deprecate that policy. So what we need to do is we need to have a plan in place to move our permissions away from the deprecated policy to the new replacement policy that AWS has created. So essentially, these are policies where we have limited control on the permissions that the policies have to offer. AWS manage those permissions, but also keep in mind that AWS can also deprecate those permissions at any time, in which case we have to have a plan in place to move our permissions over to the new replacement policy. We also have customer managed policies. Customer managed policies are created and maintained by us, so we can use those. We have inline policies. Inline policies are also created and maintained by us, but inline policies are mainly used for a single entity. It has a strict one-to-one relationship between the permission and the entity. So in other words, if I delete the identity, the permission also gets deleted. So this is one that you don't really see being used in a popular way. So it's rarely used. It's only really used in situations where you're concerned that maybe the permissions in the policy could be mistakenly assigned to somebody else. In that case, you can define a one-to-one relationship between the policy or the permissions that you're granting and the entity. So that's when this is used. So what is recommended in terms of these three types: AWS managed, customer managed, or inline policies? What is recommended is to use customer managed policies. And the reason is these four reasons that we have here. Number one, we have control over the permissions when we're using customer managed policies. Number two is we can have versioning in terms of the permission. So when we had a new set of permission to a customer managed policy, what it does is it's going to create a new version. And that means we can easily roll back to the previous version if we want to roll back. Number three is reusability. So a single managed policy, we can attach it to multiple entities. Inline policies will not allow us to do that. With customer managed policies, we can do that. And then we have management, which is the fourth reason for using customer managed policy, which means we can have central management of that. So whenever we make changes to the policy, that change is going to be applied to any identity that we've attached that policy to. So that's for central management. So that are the four main reasons why the recommendation is to use customer managed policies instead of AWS managed and inline policies. So let me look at the time here. So I'll need to round up on this aspect. So understanding AWS, understanding AWS IEM policies and how those work. So To use AWS policies, we need to understand how access is granted. And AWS is really a collection of resources. And for example, our AWS IEM user is a resource and S3 bucket is a resource. When we use either the AWS API, AWS CLI, or the management console to try to perform an action on AWS resource, what happens is it's going to create a request. And inside that request, we'll have a list of the actions that we want to perform, a list of the resources that we want to perform the actions on, and some other information relating to the request. And that's going to be submitted to AWS. And when that's submitted, AWS by default will assess every policy. So it's going to look at all identity-based policies relating to the set of actions and to the resources that we want to perform. It's going to look at all the resource-based policies. So it's going to assess all of those. So there are multiple stages that it's going to go through in terms of how it does this assessment, right? So for example, it's going to check if there's any deny. If there's any deny, it's going to deny the request. If there's no deny, it's going to check if there's any allow. If there's any allow, then it's going to allow that request to happen. So it's going to go through like that process in terms of how before access is granted. So here's a sample document that shows what the policy evaluation process looks like. So it starts with an implicit deny. So everything is denied by default. By default, no one can do anything. And then what it's going to do is that it's going to start by evaluating all applicable policies. If it finds any explicit deny, it denies that action. If there's no explicit deny that it found, it's going to start assessing the resource-based policies. If it looks at resource-based policies, if it finds that there is an allow in a resource-based policy, right? If there is no resource-based policy associated with the resource that we want to perform the action on, it's going to assess the session policy. It's going to check if this was done by assuming a session with a policy. If that is true, it's going to check if there's an allow. If there is no allow, it's going to fall back to the implicit deny, which is going to deny that action. If there is an allow, or if there's no session policy, it's going to move to assessing identity-based policy. And then it's going to assess the identity-based policy. And then if there's an allow, it's going to allow that. If there's an explicit deny, it's going to deny that. If there is no allow, it's going to fall back to the implicit deny, which means it's going to deny the deletion. So you can see that there's a whole set of steps that it goes through. There's another component to this that we'll talk about in a later study series. In this study series that we'll talk about in a later session in this study series, where it talks about service control policies, SCP, and we're going to talk about how those are also included in that assessment. So here's an example of the different elements of an AWS IEM policy. So we have three main sections that are actually required. The effect, which is whether we want to allow or we want to deny that action. The action that we want to allow or that we want to deny. And the resource that that action applies to. So those three are required. We need to specify those. But optionally, we can also add conditions. So conditions allows us to be even more granular before we grant access or before we deny access. So for example, we can specify a condition to look at the source IP where the request is coming from. And based on the source IP, we can either allow or we can deny the action from taking place. Another optional one is principal. So principal is usually one that will specify in a resource-based policy, not in an identity-based policy. So in a resource-based policy, we have to specify the principal or the identity that we want to allow or deny access to. So that's when we can specify the ARN or the Amazon resource name of that identity, including the Amazon resource, the Amazon account ID. We specify that, in the principal section. So that's an example of what that looks like. Okay, so what we'll do here is we're going to stop from this section, and I'm going to move over to talk about some web application security considerations before we go to the quiz for today. Satugo, any question at
Okay.
all?
Yes, yes, yes. I have a question from the audience from Brad Barker.
Yes.
So he wants to know this. He wants you to elaborate on entities. So like whether this applies to one tenant. So in the cloud, you have like multi-tenant or one tenant. So does it go on a tenant environment? Looking at identity IAM runs on entities, so a tenant environment on AWS. So if you
Yeah.
can elaborate on that. Yeah.
On what's it called? On entities, right?
Yes. So as an organization, so these policies you just mentioned, IAM policies on the higher level. So you talk about root policies. That root policy, does it ties to one organization, so one tenant?
Yeah. So if yes, so the idea behind that is we have AWS IEM, which belongs to an AWS, which exists in an AWS for an AWS account, right? So, but if we're leveraging AWS organizations, the approach to do that is we can have our identities maybe in a single AWS IAM, and we can grant those IAM entities or the IAM identities permissions to resources in multiple accounts in our organization. So that can be account number 2, that can be account number
Yeah.
1. So, and remember that the IAM identities can either be identities that exist in IAM, you know, our users, our
Yeah.
roles, our groups. They can also be federated users, which are users that don't exist natively in AWS IAM in any of our accounts, but
Yeah.
we're allowing permissions to authenticate and to be able to use resources in our AWS account.
So like guest users, service principals, if your organization is partnering with an external organization or APIs, coming in with a service principles, something like that.
Yes, that will be correct. Yeah. So I hope that highlights a little bit for that. Okay.
Yes, yes, I think so. Yeah.
So I'm looking at the time now because I know that people are itching to get to the quiz to win the prize. So let's get straight to the web application aspect. So what are we going to look at in this particular module of our study series? We're going to look at threats in a three-tier application or three-tier architecture. We're going to look at some common threats in terms of user access and some common threats in terms of data access. We'll look at AWS Trusted Advisor, and we'll look at some information around threat modeling a three-tier architecture. So let's get started into that. So let's get started with web application architecture overview. So this is a typical web application architecture in AWS, right? It's a very typical traditional web application architecture. So it's a very simple architecture. So here we have a public subnet, which means it has a route through an internet gateway to the internet, right? So we have a public subnet where we have some NAT gateway there. We have a private subnet. This is where we are hosting our web servers. So we have an internet-facing Elastic load balancer there, so which is distributing requests that come in from clients on the internet to our web servers posted on private subnets. And then we have our application servers living in another private subnet, and notice that those are distributed across multiple availability zones, and requests that needs to be communicated maybe to the backend data goes to the application server, which does some processing, and that comes through the internal Elastic load balancer that distributes the request to our application tier. And then we have other protected subnets where in this case we're running Amazon RDS instances for our database. And we have some synchronous data replication going between them. In terms of the certificates that's used by our web application, we can store those certificates in a service like AWS Certificate Manager. So here is a typical three-tier web application architecture in AWS. And in terms of storing maybe static content for our web application, we can store those in things like Amazon S3 or maybe for archiving, we can store some of those in services like Glacier. So what are some of the threats in a three-tier architecture in AWS? So before we do that, let's understand what is a risk assessment, right? So in a risk assessment exercise, when we're trying to understand the threats, what we want to do is we want to identify assets in our organization. What are the assets? What are the digital assets that we have that attackers may be interested in, that has sensitive information, that have proprietary information that belongs to the organization? But we also want to identify what are the weaknesses or the vulnerabilities that could be taken advantage of to compromise those assets. And also, we want to identify what are the threats, right? What are the actual threats in terms of being able to take advantage of those vulnerability, or the possibility of taking advantage of those vulnerability to access those assets. So an intersectionality of the digital assets that we have, the vulnerabilities and weaknesses in the services or in the systems, and also the likelihood of that being exploited is what we refer to as the risk, right? So that's what we're trying to assess when we're trying to assess a risk to our services or to our systems. And some of the approaches to do that is doing leveraging threat modeling. So threat modeling, we mentioned this yesterday also, it is a method for assessing and documenting threats associated with an application environment. And what that means is before we start designing our applications, we want to go through this process to identify what are the vulnerabilities that could be exploited when it comes to the application architecture that we're building. So we assign a security POC, we identify the different data flow path for our application, we perform a threat modeling session, we document the vulnerabilities and the mitigations to those vulnerabilities. So that's sort of like the process that we go through for this. So let's have a look at some example of this. So here's an example of what a data flow table looks like, right? So it's an example of a data flow table. So the data flow table is where we define how data moves within our application. So for example, we have a web server endpoint. Clients are going to interact with our web server endpoint using API calls, right? And the data direction is that data is going to flow from the customers that are accessing our web server. The data is going to flow via this API call to the web server. The connection type is going to be using HTTP, HTTPS. We're going to have some digital signature that we can use to validate integrity, right? And then we can have a table that lists who has authorization locally on that web server, right? So we want to have a look at who has authorization locally on that web server. So we can have a look and see, okay, what other data flows into our web server? So in this case, our web server is going to be communicating with the app server. So in this case, we map that and we say outbound data will flow from our web server to the application server, right? And also, in order to be able to understand what some of the risks are, we want to document who has authorization to our local web server. We do the same for our app server. Data is going to flow inbound from the web server to the app server. It's going to use HTTPS. It's going to flow via API call. We want to document who has authorization to the app server. So essentially, this is about tracing the path of data as it goes from one service within a web application to the next. And we can even create a diagram off of that. So for example, here is an example data flow diagram for a three-tier web application in AWS. So in this case, we have the diagram that shows users interacting with the web server using HTTPS via the API call. So we have the web server boundary here where we need to understand who has permissions within this boundary, right? And then we know that our web server will be making a call to the app server, and the app server is going to be making call to some credential store. We'll be using JDBC in this case. So in that case, we want to trace the data flow and we want to find out who has permissions within this boundary of the application server and the credential store, right? And then we can trace the flow of data. And then once we trace the flow of data in that path, we go through a threat modeling session. A threat modeling session is where we look at some of the things that we talked about, right? The purpose of this is to really try to understand what are the weaknesses that could be exploited. What weaknesses can be exploited as data moves from the web server to the application server? What weaknesses could be exploited? So, for example, people could send SQL injection in the call that made to the web server, and what that means is we need to validate the inputs that come in from clients before we send that to the application server, right? Or before the application server sends that to the data service backend, we need to validate the input. So that's the whole point of going through like a threat modeling session and going through that. So, and then the end result of this is we want to document the vulnerabilities, right? So we want to document the vulnerabilities that we've identified. And this is where, again, the STRIDE model that we made mention of yesterday comes into play again. Document the vulnerability, but also document the mitigation against those vulnerabilities. And then what you want to do is you want to assign those responsibilities to different team members that will take responsibility for mitigating the vulnerability that you've identified. So here's an example of the STRIDE model that we referred to yesterday. So STRIDE stands for spoofing and just different vulnerabilities that exist. So we talked about that yesterday. So that includes tampering, repudiation, denial of service, elevation of privilege, and other types of attacks like that. So here are some of the common threats when it comes to user access that we can review, right? So for example, we have common threats when it comes to user accessing our systems unauthenticated access. It's a common threat. So what we do is we map that against the STRIDE vulnerabilities of spoofing, repudiation, and elevation of privilege, right? Another one is unauthorized access. So a user is authenticated, but they should not be authorized to perform an action. But so we can map those to spoofing, repudiation, elevation of privilege. Another one relates to password policy. So maybe an attacker could exploit weaknesses in a password policy to access an authorized resource. So we can map that to the, again, the STRIDE vulnerabilities. So unauthorized SSH access, we can map those to the STRIDE vulnerability. So define what the risk is and map that to the STRIDE vulnerability. So here are some common threats when it comes to data access also. So when it comes to data access, we have where an attacker could compromise the data store where encrypted data and the encryption keys are stored. So we map that to information disclosure. So that's mapped to compromised keys. Credentials storage. So again, we describe what that looks like and we map that to the associated STRIDE vulnerability. So looking to round up here so that we can get to the quiz. Any questions that come in, Sachugo?
Yes. So we have a question. I think it's a bit generic. So it was asked by Arnold. So he was asking, what's the difference between a private subnet and a protected subnet?
Okay. So a protected subnet just means you have more restrictions for those, right? So I'm guessing you're referring to like the network architecture diagram that I had at the top there. So I have like a network architecture diagram there. So if you think about something like a private subnet, for example, a private subnet can still communicate with the internet, right? So yes. It still has direct communication with the internet. If I go back to that diagram, this one, right? So this can still communicate with the internet. So for example, this can still communicate using the NAT gateway, right, to communicate with the internet. But protected subnet essentially means an isolated subnet is what we're talking about here, right? So where the only thing that can communicate directly to this at the, any instance in a private subnet, and that's it. So it's not internet connectivity or none of that.
So I think like Active Directory is a candidate for that.
Yeah, exactly.
Yeah.
Exactly, sir. Yeah. So things like that. Yeah. Those will be in a protected subnet, no internet, direct internet access. Okay.
That's the only question we have. So let's go to the quiz. I'm looking at the time.
Um, yes, I'm looking at the time now, but before we get to the quiz, I'll just quickly talk about Trusted Advisor very quickly. So, in terms of assessing overall security, one of the services that we have in AWS that we can leverage to assess overall security is a service called AWS Trusted Advisor. So this is sort of like your private consultant on AWS, right? It's your private consultant that can give you recommendations, can give you recommendations regarding your service limit. Hey, you're about to get to the limit of this service. You may probably want to maybe spin up another AWS account or something, right? So gives you recommendation relating to fault tolerance, gives you recommendation relating to what we're talking about, security, gives recommendation relating to performance, gives recommendation relating to cost optimization. So this is a completely free service in AWS, right? And we can get some security recommendations from this service. So when it comes to the security recommendations, here's what that's going to look like. So for example, yes, Trusted Advisor giving us some security recommendations in terms of our web application implementation on AWS, right? So for example, it's sharing some information to say, hey, you have some security groups with ports that are unrestricted. So you've not restricted access to specific ports. You've just opened all the ports to all IP addresses for that security group. You may want to go restrict that. So in some cases, it's identified that we have root accounts without MFA, or in terms of we're not really creating a IEM user, so it can identify some of those security issues, and then it can provide guidance to us or recommendations to us regarding those. What security checks does Trusted Advisor have for us? So it has security checks relating to all of this. Security checks relating to unrestricted security groups access, unrestricted ports for security groups in terms of our use of IAM, MFA on root accounts, S3 bucket permissions exposed to the public. So IAM password policy being weak. We've not enabled CloudTrail login, which affects auditability and traceability. Amazon RDS security group access risk, the way we've configured our security group puts it at risk. So relating to elastic load balancer, listener security, or security groups relating to our ELB. IAM access key rotation, we're not rotating our access keys, like what we talked about earlier. It can give us recommendation and advice us on those. Amazon EBS public snapshot. So this is not a good one. You have your snapshots of your disks that are open to the public. So it's going to flag that to us. Amazon RDS public snapshot, again, is going to flag that to us. Or we have some mail record or SPF records in Amazon Route 53. We have some of those record sets is going to flag those to us. So those are some of the recommendations that Amazon Trusted Advisor can give to us. And finally, we have AWS IQ, which is a way for us to connect with third-party experts to help us to maybe do some security assessment work. So some organizations may find this to be useful. So this is actually where from within the AWS console, we can connect third-party security experts to take on some work for us. So that is what this is about. Okay, so this is where we'll stop for this for today. So I try to go through that very quickly.
Yeah, exactly. Yeah, it's quite a challenge. I can imagine, right, to get everything undone. So let's go to the quiz. So tell us how we're gonna get this voucher. It saves a lot of money.
Okay, so in Jita, let me see. Did you send because in Jita won yesterday? So did you send me your email address? So make sure you send us your email address so that we can send your voucher that you won yesterday to you. So there is some ground rules. So especially for Injita, you can only win one of our prizes once, right? So we don't want someone like an expert like Sachugo coming in every week and winning all the prizes. and everyone else is feeling what's all of this, right? So we don't want that. So you're only allowed to win one of our prizes one time. So in Jita, I would advise not to play this round of game because you're not going to be allowed to win a prize again. So, but that being said, let me go ahead and create the Kahoot link that we're going to be using for the quiz today. So let's go ahead
Okay.
and let's create that. So what I'll do is this, I'll put a link in the chat window, and I will also share my screen so that we can see the screen. So let's do that. So the link is in the chat window now, and let's go ahead and let's share the screen. So my screen should be visible now, sir, right?
Yes. Yeah.
Awesome. So if you go to www.kahoot.it and you put in the PIN number of 9617855, 9617855. So we got Prabhu and we got Tolu. Got Dean and Peter Pan. So I recognize some of these names from yesterday. And we got Balaji. Okay, we just give it a few more seconds, and then we're going to kickstart the quiz. So again, remember what is at stake in this quiz is an AWS security certification voucher. So it's worth about
Yes.
$300.
That's what at
So
stake. I hope Orieta is not part of it.
yeah. Oh,
Rita,
Rita probably she's probably the one masking herself. She's probably using a
I think
different
so. Yeah.
Okay,
She's
let's
always
go
there.
ahead. Yeah, I think so. So let's go ahead and kickstart. So remember that the questions are not necessarily tied to what we discussed today. So you have to be on your game, on your AWS security game whenever you're attending any of our sessions. So question number one, you need to inspect the running processes on an EC2 instance. How can you achieve this in the easiest way possible?
All the time is going so fast.
Yep.
But
Got to be able to read those answers very quickly and pick your answer. So let's see. And the answer to this is B. Use the SSM run command to execute a command on the EC2 instance is the answer to that. So that's the way to achieve that in the easiest way possible. So none of the other options achieves that in the easiest way possible. So 4 people got that correctly. Let's see who is at the top of the scoreboard. So we have Peter Pan at the top of the scoreboard, followed by Tolu. So well done. So next question. You need to detect if port scans occur on your EC2 instances. What should you implement? So let's see. So the answer to this one is to use AWS Guard Duty to monitor any malicious port scan. So 6 people got that correctly. Let's see what the scoreboard looks like. Oh, and now we have got Tolu and Prabhu leading the scoreboard now. So let's see. So we have the next question. Number 3. Security auditors need a list of AWS services that meet PCI compliance. How will you do this? And the answer to this one is A, download PCI compliance document from AWS Artifact. So this is a very interesting one, Satrigo, because this
Yes.
question is checking not of your AWS application, is checking for a list of AWS services that meet PCI compliance. If you want to get that information,
Okay.
you
Yeah.
go to an AWS service called AWS Artifact, and AWS publishes in that service, they publish a list of their services that meet different compliance requirements. So that's what they do. So you can download the reports
Yeah.
there.
Okay.
So
I've
let's
not used this
see.
before.
Yeah, it's a very interesting one, right? So let's see what the scoreboard looks like. Any changes? We still got Tolu. Now we have followed by Peter Pan. So well done. So Tolu started on fire. Tolu has a streak of 3 correct answers in a row. So well done. So next question. You need to ensure that EC2 instances don't have any high security vulnerabilities. How can this be achieved? So let's see. We've got 6 people that got that correctly. So the answer to that is to use AWS Inspector to assess the instances. So let's see what the scoreboard looks like. We've got Tolu and Peter Pan still leading, and Tolu with a streak of 4 correct answers in a row. Wow, that's amazing. That's impressive.
Exactly.
And yeah, that's impressive. And the final question for today, ladies and gentlemen, this is the final question.
Last
You want
chance.
to, yeah, you want to ensure that instances in a VPC uses your managed DNS instance and not the default. How can this be achieved? And let's see, the answer to that is create a new DHCP option set and replace the existing one. So if we want to use our own managed DNS instead of the default Route 53 option that we get, so we don't want to use the default option, then what we do is we create a new DHCP option set and apply that to our VPC. So let's look at what the scoreboard looks like. And on the podium, number 3, we have Prabhu. Well done, Prabhu.
Wow.
And number 2, we have Peter Pan. And number 1, I think we can probably guess. We have Tolu with this one. So, and we have Dean and Johnny for the 5th places. So congratulations to you, Tolu. So what you've done is you've won an AWS security certification voucher. So what I'll do is I will put a link. Sorry, I'll put our community email in the chat window. So send us your email send an email to us via the email address. So, and then what we'll do is we'll get your email address to AWS, and then they will send that to you. So, Tolu, there you go. So that's the email address to use. So send that information to us, and we'll get that to you. So Unjita won yesterday the voucher. So Unjita, make sure you send us again. Make sure you send us your email address, because that's how we're going to be able to get your voucher to you. If you don't send it to us, we won't be able to get it to you. Tolu, make sure you send us your email address, and then we can get the voucher to you. I can see that you said the latency is not fine at all. I'm not sure what happened there, but I'm not sure. Is anybody else experiencing any latency issue? So hopefully that's not a common issue. So Satsugo, anything that you want to say before we round up today's study session?
Well, wow, quite a nice section. I learned something new today from you, especially the artifacts. I never used that tool from AWS. Yeah, thanks for the participants. Tolu, I hope you enjoy the voucher and to pass your exam. Yeah. So going forward, I would be taking you guys on the 19th December on another interesting section on AWS. So we'll be talking about application security on AWS. So I hope you will enjoy it, and I hope you will participate. It will be fun. And yeah, hope you enjoy your evening.
Sir David, for you. Any prizes for your session? Any prizes that anybody will be winning?
Of course, that would be a secret. Of course, that would be a prize to be won. There's a takeaway, you know, yeah. And that would be a consultation prize, you know, for the if you're second. Yeah.
Whoa, that's a new one. Yes, so ladies and gentlemen, because we only give like prizes to the top one, but Satsugo is announcing that there will be another prize, a complimentary prize for the second position. So make sure you come prepared. Make sure you come prepared for next week.
Nice. Thanks for the time. Hope you guys will enjoy your evening.
Yeah, see you next time, ladies and gentlemen.
Bye, guys.
Bye for now. Bye.
Ciao. Bye.